Analysis of variance. ANOVA. ANOVA is a powerful statistical procedure for determining if differences in mean are significant and for dividing the variance into the component. Variance square, sigma square. It is absolute measure of dispersion of raw scores around the sample group means the dispersion of the scores resulting from their varying differences year term from the means. The square standard deviation is called variance and it is denoted by sigma square, mean square. The measure of variability used in analysis of variance is called a mean square. Sum of square deviation from mean divided by degree of freedom. Mean square is equal to sum of square deviation from mean and degree of freedom. Mean square, sum of square deviation from mean and degree freedom. Assumption in the analysis of variance. The sample are independently drawn. Second, the population are normally distributed with common variance. Third, they occur at random and independent of each other in groups. And fourth, the effect of various components are additive. Techniques for analysis of variance. One-way ANOVA, here a single independent variance is involved. Example, effect of pesticide, independent variable. On the oxygen consumption, dependent variable in a sample of insect. Two-way ANOVA, here two independent variables are involved. Example, effect of different level of combination of a pesticides, independent variable. And an insect hormone is independent variable on the oxygen consumption of a simple insect. One-way classification. In one-way classification, data are classified according to only one criteria. The null hypothesis is H naught is equal to mu1 is equal to mu2 is equal to mu k. H1 chunki mu1 is not equal to mu2 is not equal to mu k. That is arithmetic mean of a population from which k samples are randomly drawn are equal to one another. The step is carrying out the analysis are calculate variance between the sample, calculate variance within the sample, calculate the F ratio, and D. Compare the calculated value of F with the table value of F for the degree of freedom at a certain criteria level, critical level. Generally, we take 5% level of significance. Analysis of variance ANOVA table, one-way classification model. Source of variation, SS, sum of squares, V, degree of freedom, MS, mean square, and variance ratio of F. Between sample, SSC, sum of SSC, degree of freedom V1 is equal to C minus 1, MS mean square, MSC is equal to SSC upon C minus 1. Within the sample, SSE is the SS and V degree of freedom V2 is equal to N minus C. MS square mean is equal to MSE is equal to SSE upon N minus C. Variance ratio MSC upon MSE. Total SST degree of freedom N minus 1. SST total sum of square of variations. SSC sum of square between samples columns. SSC sum of square within sample rows. MSC mean sum of square between samples. MSC mean sum of square within samples. Rationales of the test. The variation within the sample are the variation of the individual observation within the samples from their own individual samples means measure the influence of the chance forces which cause the individual observation to vary from one another. However, the variation of the k samples means from the grand sample means of all the samples taken together, i.e. the variation between the sample means reflect not only the effect of these same chance forces but also the effect of forces, if any, which cause the various sample means to differ from one another. Thus, if there is any such force, if the hypothesis is not true, variation between the sample means will tend to be greater, larger than the variation within the sample, and this is precisely what the test is designated to identify. Two-way classification: when it is believed that two independent factors might have an effect on response variable of interest, it is possible to design the test so that an analysis of variance can be used to test for the effect of the two factors simultaneously. Such a test is called two-factor analysis of variance. Within the two-factor analysis of variance, we can test two sets of hypotheses with the same data and the same time. In two-way classification, data are classified according to two different criteria or factor. Analysis of variance, ANOVA table, two-way classification model, source of variation, sum of squares, degree of freedom, mean sum of square, and ratio of F. Between sample, sum of square SSC, degree of freedom C minus 1, mean sum of square MSC is equal to SSC upon C minus 1, ratio of F is equal to MSC upon MSE. Between the ratio, sum of square SSR, degree of freedom R minus 1, mean sum of square MSR is equal to SSR upon R minus 1, ratio of F is equal to MSR upon MSE. Residual or the error, sum of squares are SSE, degree of freedom C minus 1 multiplied by R minus 1, and mean sum of square is equal to MSC is equal to SSC upon R minus 1 C minus 1, and total sum of square are SST and degree of freedom is equal to N minus 1. Here SSC sum of square between columns, SSR sum of square between rows, SSC sum of square due to error, SST total sum of square. SSC sum of square between columns, SSR sum of square between rows, SSE sum of square due to the error, and SST total sum of squares. Thank you. This is all about the ANOVA, analysis of variance ANOVA. Two-way classification model and one-way classification model.